It is about 5:30 here on Tuesday, March 18th, 2025. And another viewer had an excellent question. So I got two excellent questions on my channel yesterday, and this is the second excellent question. The question had two parts. The first question was about average temperature, why that's a meaningless measure. And the second part was about rainfall, desertification, storms, cold snaps, that kind of stuff, right? So you'll note that this has to do with a certain topic that I'm not going to try to mention. The reason why is I don't want my channel to get flagged as that kind of channel. So my background, I studied physics. I was a computer science major, but this is one of those topics that I really looked into. I read a lot of research papers on this. I really understand what they're doing and how it works. And I don't have a positive opinion about it at all, okay? And there's a couple other physicists on YouTube that share my opinions on this. The vast majority of physicists on YouTube, they are going to toe the party line, because if they don't, they will not get money, okay? And that's the bottom line there. This has to do with money. And so if you don't toe the party line, you're cut off from money. You can get disqualified from all kinds of things. So I'm trying not to use the magic words. Okay, average temperature. So what does average temperature mean? Well, average means you take like a whole bunch of things, add them together, and divide by the number of things. And why can't you do that with temperature? There are certain quantities in physics that you can take the average of and get a useful number out of. A good example is like mass. Okay, so if I had a thin rod with masses hanging from the rod, I can take all the masses times their position on the rod and then find the center of mass by taking the average, okay? However, temperature is not that kind of thing, right? Adding temperatures together makes no sense, okay? Multiplying temperatures makes no sense. Dividing temperatures makes no sense, right? Temperature is a weird sort of quantity that if you must know what temperature actually is, it has to do with the question of how energy can be distributed within a system. It has to do with like entropy and all that kind of stuff, right? And so what's really happening is you have two different systems that come into thermal contact with each other, and then temperature is the thing that becomes the same between the two things, right? And so one thing might be more massive or might have a different type of mass. Another thing might have more energy inside of it. And that energy between the two systems will allocate itself in such a way that the temperature will be the same. Okay, now a cold thing in thermodynamics, when you look at a cold thing, what that means is that if you were to put a little bit of energy into that system, it would be able to allocate that in many, many, many different ways. Okay, so there's lots of little places to put that energy. A hot system says if you were to add a little bit of energy in there, there's not as many ways to put it, right? And so that's what temperature means. And so taking the average, adding temperatures together, dividing them does not make any sense, right? Masses, you can add them together. If you have two masses, they stick together, the mass doubles. Velocities, you can add velocities. They're vectors, you can add them, multiply. You can divide velocities. There's, that's the kind of stuff means stuff. But with temperature, that doesn't mean anything, okay? Now, the meteorologists out there, they talk about like the average daily high, or they talk about, the average is increasing or whatever like that. What they're really talking about is they took measurements on particular days throughout history, and they measured maybe the high temperature or the low temperature or something like that. And then what they're giving you is kind of a prediction based on past behavior of what could happen in the future. Okay, unfortunately, meteorologists are not very good at sharing their error bars. Okay, they don't share their confidence intervals. And so when they tell you that the average temperature on, let's say, March 1st throughout the history for my particular area was 65 degrees, what they're not telling you is that they're like 25% of the days were actually below freezing or something like that, right? Or maybe 25% of the days were above 80, okay? So if you were to use the average temperature to predict future temperatures, then you need to know the error bars. You need to know the confidence interval, right? So that's going to look like something like the average temperature was like 68 degrees plus or minus 20 degrees, okay? And so any range between like 88 and 48 is within, normal, right? It's well within predictions. But if you do like a 95% confidence interval, then 5% of the values are going to fall outside of the confidence interval, right? And so don't be too surprised. That's only 1 in 20. If you have a 99% confidence interval or 99.99% and it falls outside, then you're like, well, this is historically significant. If like 1 out of 100 days on that particular day in March for the past 100 years was beyond a certain number, then yeah, that's statistically, it's an anomaly, right? It doesn't happen that often. It's pretty rare. Okay, now in particle physics, which was kind of the area of physics that I spent the most time learning about and doing work in, they use 99.99 or 99.999, which means like 1 in 1,000 or 1 in 10,000 numbers will fall within the confidence intervals. Okay, they're allowed to do that because they can, and also because they want to be extremely precise with these values that they determine. Okay, temperatures are not that kind of thing. Okay, it's a different kind of science. It doesn't have the same kind of confidence intervals. And so the average temperature really doesn't mean much to me. Okay, so if you told me that the average temperature for March 18th or March 19th, which is tomorrow, is some number, I'd say, so what, right? Because I know the confidence interval is huge. Okay, now I don't expect to get sub-zero temperatures tomorrow, right? That's probably not going to happen. It probably never will happen, but I'm not surprised if it's 90 degrees tomorrow. That's not that amazing for this area. Okay, the second question is, all the anomalous behaviors, and so you read newspaper articles about how, this is historically unprecedented. We have wildfires, I'll add to that list. We have, tornadoes and hurricanes, and we have all these weird things happening with rainfall, like we're getting too much rain and now we're getting too little rain. And some areas are turning to desert. Cold snaps. They make a big deal lately about anytime the temperature gets a little bit cool, they say it's a cold snap. And lately in different places, if it gets above 80 degrees, they're like, it's so hot outside, we're all gonna die, you know what I mean? So a lot of that stuff that you guys are hearing about is exaggeration. And you can do yourself, go back throughout history and look, like back in the 1920s is a good era to look at, and see what kind of events were happening back then. Pull up newspaper articles from the 1920s and go see what kind of anomalous weather events they were having back then. And you look at today and you see that today it's just people are much more sensitive to stuff that's happening, right? Okay, I'll tell you another thing too. You might think rainfall, that's something that should correlate very strongly with temperature, and I think it does, okay? Everything that I know about how weather works, I think it does. Higher temperatures means more rainfall. Okay, when the average temperature goes up, you're going to get more rain. But here in my part of the country, I'm just on the southeast corner of the Great Plains. Rainfall is random. I could pull up a map at any time and say, we're getting rain around me, but it's not landing on my farm, right? So it's kind of a random event, So it's not really if I get more rainfall or less rainfall, that just means, I had a lucky year that year or a not so lucky year that year, right? All around me, they might be getting plenty of rain. So it kind of doesn't mean much. Okay, the last little bit is people, and I'm not going to name names, are using what's called a model, okay? And what a model is it's a mathematical formula that's used to calculate things, right? Typically, they want to predict what's going to happen, And so what you do is you feed a bunch of data into this algorithm, and an algorithm is just a way of solving an equation, basically. You feed a bunch of data into this algorithm, and then you run it through, and you get back a set of parameters that generates a model, a formula, for determining what the weather is likely to be, okay? Now, the problem with these weather models is they are all very, very wrong, okay? And using these models at all for anything is academically dishonest. And another thing that they've done is they've taken the models that say things they don't want to hear and just thrown them out the window. They've only taken the models that say the things that they want to hear, right? So there's politically correct models and there's politically incorrect ones. And the ones that are politically incorrect are just thrown away and ignored, okay? The equations that you would use in physics to solve the kinds of problems that they're trying to solve are well known to be unsolvable, okay? You might have heard of chaos theory if you watched the original Jurassic Park way back in the 90s, I think it was. The mathematician dude, he talks about chaos theory, like if the drop lands on your knuckle, it can either go left or right. You can't predict, that kind of thing. That is not really chaos theory. It's like correct, but it's not really the idea behind chaos theory. There are certain equations in mathematics and physics that if you change the parameters to those equations, the results will vary by a huge margin, right? And so that's why you hear something like, if a butterfly flaps its wings in Africa, then there's going to be a hurricane that hits New York City, right? That's what the equations do. And so these equations, even though we understand like how things behave, we can't roll it out to predict the future in terms of weather and these systems. Okay, it's just too unpredictable. The best we can do is look back in time and see what has happened, and based on that say, well, you know, it's more likely to see the same kind of behavior in the future that we've seen in the past. But even then, that's a problem, because we know, based on, you know, we've looked at the soil, and we've looked at the dirt, and we've looked at the trees, and we've looked at the fossils. We know that Earth's climate has changed over time, right? And so is Earth's climate changing right now? The answer is yes, because it never stops changing, okay? The Earth's climate never stops changing. The other question is, well, how is it changing? And the answer is nobody knows. We cannot predict how the climate is changing. We don't have a clue, okay? The last question that people ask is, what can we do about it? And the answer is nothing. You can't do anything about it, because we cannot predict how it's going to change, and therefore we cannot predict how our behavior will change its outcome, right? These equations are inherently chaotic. A small change can move the thing one way or the other. There's no way of telling. Maybe it'll do nothing, okay? This is really one of those things where you just say it's in God's hands, because we can't do anything about it, okay? Now, if you're wondering, people have done like mental experiments about what would happen if we dropped a nuclear bomb in a hurricane in the ocean. The idea was that maybe we could stop the hurricane from forming, right? And even with that, you know, you'd think that maybe the biggest nuclear bomb would have an effect on a hurricane. The answer is we don't know what would happen, right? There's too many variables and too many ways things can go wrong. So, or right, or in between, or nothing at all, right? We just don't know. It's too chaotic. The last little bit I want to add is the people who have been publicizing and publishing these studies and warning people about the end of the world and how we have to change our behavior and we have to, you know, stop using this and start using that. Those people have been caught lying multiple times, and they've covered up their lies. They've tried to, like, what's that? I've investigated myself and I haven't committed any crimes type of stuff, right? They were absolutely caught with their pants down several times. They refuse to release their raw data. They do not give that raw data out to anybody, okay? Because they know if they showed that raw data to anybody, then anybody like myself or anybody else with even a little bit of science education could look at the data and show that they are completely full of bunk, right? Their equations and their formulas do not work, and everything they say is just basically made up garbage, okay? And that has been true for a very long time now. You can go online and you can find people who will show you where they have been dishonest with their data and their formulas and their algorithms and all that kind of stuff, okay? So I don't really have much else to add on this. If you want to keep believing these people, if you want to keep listening to their doomsday scenarios, if you want to believe that if you do one thing or another, it's going to affect the climate, you can do that. But just understand that you're in a cult. You're in a religion, okay? It's the same as sacrificing virgins to the volcano. There's literally no difference, because you cannot affect these things, okay? So if you want to go ahead and feel good about yourself and, you know, dance around the fire and stuff like that, you're free to do so. And I encourage you to do whatever makes you feel good. But don't go around telling other people what to do, okay? Don't pretend like you know what you're talking about. And certainly don't pretend that you are science. Okay, guys, have a great day. Take care, and bye-bye.